This video is the first half of a review of all the derivative rules we have learned in AP Calculus. For problem number 1, we will simply use the power rule. So f prime will equal 10x to the 4th power. I'm multiplying this 5 times the 2, reducing the power by 1, and I move on. When I take this 3 and I move it to here, these 3's will cancel each other out. So that will leave me with negative 4x to the, and I reduce this by 1, so I have x squared. Then the derivative of 7x is 7, and the derivative of 2 is 0. So this is the answer to number 1. For number 2, we will use the chain rule. The 2 just sits there. The derivative of cosine is negative sine. So I'm going to go ahead and put sine 3x, and I will put the negative that I mentioned out in the front. But because we have this function inside of a function, we must then multiply by the derivative of the inner function. The derivative of 3x is 3. So we could leave the answer like this, but I'm going to go ahead and put y prime is equal to negative 6 sine 3x. So that's the answer to number 2. Number 3, here comes the chain rule again. G prime will equal, first we take the derivative of the outer function. So the 3 comes to the front. We reduce the power by 1. And we leave the 2x plus 3. But because we have this inner function, we must multiply by the derivative of this inner function, which will just be 2. This could be the answer, but I'm going to go ahead and multiply the 2 times the 3 and write 6 times 2x plus 3 squared. This will be my final answer for number 3. Before we take any derivatives on problem number 4, I want to rewrite the function a tiny bit. So f of x equals x squared times e to the x to the negative 1 power, because 1 over x is the same as x to the negative 1 power. On the next step, we will use the product rule, looking at f of x as this factor times this factor. So here we go. F prime will equal, the first time through, we take the derivative of the yellow factor, which is 2x, and we leave the blue factor alone. So we still have e to the x to the negative 1 power. And then we put a plus. The second time through, we leave the yellow factor alone. So I have x squared. But then I take the derivative of the blue factor. We learned a long time ago that the derivative of e to the x is very special because it remains e to the x. So in this problem, the derivative of e to the x to the negative 1 power will remain e to the x to the negative 1 power. However, because we have this inner function, not just a plain x, we do have to apply the chain rule and multiply by the derivative of this inner function. So the derivative of x to the negative 1 power, you move the negative 1 to the front, reduce the power by 1, and you get this. On my next step, I'm going to take this negative sign and move it to the front. So this plus will become a minus. However, notice that if we multiply x squared times x to the negative 2 power, those are going to cancel each other out. Because when you multiply with like bases, you add the exponents, and this will just make x to the 0 power, which is 1. So these will be gone. So now we have this, but I see that we have a common factor of e to the x to the negative 1 power here and here. So let's go ahead and factor that out and put it in the front. So we have f prime is equal to e to the x to the negative 1 power times 2x minus 1. For my final answer, I will put x to the negative 1 power back to 1 over x. But this will be the final answer. On number 5, before we take any derivatives, I want to rewrite the function a little bit. Focus on the inner part, 1 over t minus 3. If I bring this out of the denominator, I could write it as t minus 3 to the negative 1 power. This would be the same as this inner part. But then I have this cube happening on the outside. So when I have a power raised to a power, of course I am going to multiply these. So this will end up as simply t minus 3 to the negative 3 power. So we have this so far. We will have to be very careful on this problem because we have the variable t. In the directions, we are told that we must take the derivative with respect to x. So don't forget about that. So there's a bit of an implicit differentiation happening because the variables do not match. So if we begin to use the chain rule and take the derivative of the outer function, we have y prime equals, the negative 3 comes to the front, and we have negative 3 times t minus 3. We reduce this by 1, so we have the negative 4 power. And then we multiply by the derivative of the inner function. If we were taking the derivative with respect to t, this would just be a 1. But we are not. We are differentiating with respect to x. So the derivative of t with respect to x is dt dx. And of course the derivative of a constant is 0. So that's it. But we just have to be careful to put this dt dx instead of a 1 because the variables do not actually match. You might also see the answer written this way on a multiple choice question by taking the t minus 3 to the negative 4 power and dropping it down to the denominator. Before we begin problem number 6, I'm going to rewrite this a little bit. We have f of x is equal to x times, but instead of the square root, it will be more convenient to write this as the 1/2 power. We're going to need the product rule, so I'm going to look at f of x as this factor times this factor. So when I write f prime of x, the first time through I take the derivative of x, which is 1, which I really did not need to write, and then I leave the second factor alone. So I have 1 minus x squared to the 1/2 power. And then I put a plus. The second time through, I leave the first factor alone. And I take the derivative of the second factor. So this 1/2 is going to come to the front. So I'll just put it right here for now. And I have to reduce this power by 1. So this will become negative 1/2. I've got the 1 minus x squared on the inside. Because we have this function inside of a function, we use the chain rule and multiply by the derivative of this inner function. So the derivative of 1 minus x squared is negative 2x. Notice that we have a 2 in the numerator and a 2 in the denominator. So on the next step, those will cancel each other out. Also notice we have this negative sign. That's going to end up right here. So on the next step, this plus will become a minus. And notice that we have x times x. So that will be x squared. So now we have this. Notice that we have a common factor in both terms. We have 1 minus x squared here, and we have another 1 minus x squared here. To simplify this according to the directions at the beginning of the problem, we need to factor this out. So I'm going to have f prime equals, and out in the front I'm going to have 1 minus x squared with some kind of a power. But which exponent will I use? Always use the lesser exponent. So I'm going to pull it out with a negative 1/2 power. To figure out what is left inside the parentheses, I need to divide each term by 1 minus x squared to the negative 1/2 power. When you divide with an expression that has an exponent, you subtract the exponent. So I need to subtract negative 1/2 power in order to divide here. But minus a negative is addition. So even though I'm dividing, it's going to end up being 1/2 plus 1/2. And a half plus a half is a whole. So this is going to be 1 minus x squared to the 1 power. So I don't need to write that, and I don't even need parentheses anymore. So I just have this. On the other hand, notice how the factor that is out here in the front is the same factor that I have right here, including the exponent. So I've taken this entire factor away. Blam! So this whole thing is gone. So I am left with just the minus x squared part. So that's probably the simplest way to look at it. Another way to look at it, if you wanted to be consistent with what I did on the first term, is, well, I'm dividing here, so I must subtract negative 1/2, which ends up being plus 1/2. But negative 1/2 plus 1/2 is 0. And if you have something raised to the 0 power, it is a 1, which you don't need to write. So that's kind of the long way to think about it. On the next step, so far I just brought down this yellow part unchanged, and I see like terms here. I'm going to have the 1, but negative x squared minus x squared is minus 2x squared. I am infringing on the next problem, so I'm going to move this off to the side and make a new column. The directions said to write this as a single rational expression, which means I need to write this as a fraction. So I see the negative exponent here, so I will drop this down to the denominator, and I will have 1 minus 2x squared in the numerator over 1 minus x squared to the positive 1/2 power. I might also go ahead and write this denominator using a square root. So I will have 1 minus 2x squared over the square root of 1 minus x squared. So this is how you might see it on a multiple choice question. On problem number 7, we will need to use the chain rule twice. So I'm going to have h prime at x equals. First, I take the derivative of the outer function, which is this, the parentheses squared. So I'm going to take this 2 and put it over there. Maybe I'll just leave it for a second. So I'm going to have 2 over 4. Obviously, that's 1/2. And then I reduce this power by 1. So this is just a 1, which I don't need to write. But then I have the inner function sine 2x. So according to the chain rule, I must now multiply by the derivative of this inner function. So the derivative of sine x, we still have an outer function and an inner function. So the outer function is the sine x, and the inner function is the 2x. So if I take the derivative of the outer function, the derivative of sine is cosine. So I will now have cosine. And then, but I've got the inner function 2x still. So that's why I need to do the chain rule again and multiply by the derivative of the inner function 2x. And that is 2. So this is one version of the answer, but let's clean it up. I'd say let's please clean it up. 2 over 4 is 1/2. And then 1/2 times 2 is 1. So these constants cancel each other out. So we will just be left with sine 2x times cosine 2x. And this is the final answer. We can easily solve number 8 using a memorized rule for the derivative of a to the u. It helps me remember the rule if I start by remembering that the derivative of e to the u is e to the u. Of course, we have to multiply by u prime because of the chain rule. Now, similarly, the derivative of a to the u starts off as a to the u. However, because this is an a and not an e, there's this extra part where we have to multiply by natural log a. And of course, we still have to multiply by u prime because of the chain rule. Applying this memorized rule to this problem, y prime will equal a to the u. So that's 2 to the negative 3x power. And then we multiply by the natural log of a. So times the natural log of 2. And then, of course, times u prime. U is negative 3x, so we multiply by negative 3. And that's it.